This video series has been made to study science subject SEE examination. In this series, we have been solving questions of previous board exams. Now we are going to discuss answers of model question set number 7. In this video, we are going to discuss answers of group D. Answers of group A, B, C have been discussed in previous videos. Question number 21. Why the apparent weight of a freely falling object is 0. The mass of the Jupiter is 19 into 10 to the power 6 kg and that of the Earth is 6 into 10 to the power 24 kg. If the distance of the Jupiter from the Earth is 629 into 10 to the power 6 kilometer, then what will be the gravitational force between these masses? So this is numerical problem. The first part of the question is why the apparent weight of a freely falling object is 0. The weight of a body in free falling condition is 0. Why? That is your question. The apparent weight of freely falling object is 0 because acceleration due to gravity and acceleration of the freely falling body. Acceleration at which the body is falling freely in free fall condition, that is equal. These two values are equal. Okay, that is why apparent weight of freely falling object is 0. Now we can understand it more in this manner. Let R be the normal reaction or the force due to weight of the body. Force due to weight of the body R. Then we can write it this way: R equal to F or ma, force equal to mass into acceleration, or here force equal to weight. That means this is the simply weight at rest condition. When the body is at rest, then there is this force working on the body, ma. Okay, body is at rest, ma. When the body starts moving upward, now you have to consider two conditions here. If the body starts moving upward, yes, in that condition weight of the body will be moving up. At the same time, force due to gravity, pulling force of gravity is also moving upward along with the weight of the body, because this mass of the body is being acted by gravity at the same time. Okay, there is weight because of this gravity also, right? Both of these weights will be moving up together as a single unit, so in the upward direction. But when the body is moving downward, in case of free fall condition, okay, so gravity, the force of the gravity will be stronger. It is greater than the force due to the weight of the body, right? That is why it is greater. It is written in front over here. So force due to gravity and force due to weight of the body, right? So these two will be moving downward, but in this case gravity, force due to gravity will be bigger. Okay, and difference in these two forces will give the weight or the reaction, normal reaction. Okay, weight in free fall condition. Difference in these two will give weight in free fall condition, right? Because when the body is falling down, force due to gravity is greater than the force due to weight of the body, right? So now we can write it in this manner. For free fall condition, normal reaction is simply weight of the body at that particular condition is mg minus ma. Okay, this is force due to gravity, this is force due to weight of the body, right? So here m is common, you can take this out as common, then g minus a. Now here in g is acceleration due to gravity and its value is 9.8 meter per second square, right? But the acceleration of freely falling body, its own acceleration is also the equal to this acceleration due to gravity. These two values are same, okay, equal. Okay, so this is also 9.8 meter per second square. So difference in these two will be 0. Okay, so 0 multiplied with 0 will be 0. That is why reaction force is 0 in free fall condition. Because of this reason, apparent weight of freely falling object is 0. You can understand it this way. Now for your answer, you can write this statement. Apparent weight of freely falling object is 0 because acceleration due to gravity and acceleration of the freely falling body, acceleration in free fall condition, yes, is equal. These two have same value. That is why apparent weight is 0. Okay. So simply you can write this equation in your answer. This equation in your answer. Now second part of the question is numerical problem, which says the mass of the Jupiter is 19 into 10 to the power 6 kg. Means this is capital M because Jupiter is bigger with bigger mass, and that of the Earth is 6 into 10 to the power 24 kg. This is a small mass M, small m. If the distance of the Jupiter from the Earth is 629 into 10 to the power 6 kilometer, distance is given in kilometer, you have to change it into meter. When you have to change kilometer into meter, you have to multiply it with 1000. Okay, so 1000 meters equal to 1 kilometer. Then it will be 10 into 10 to the power 9 meter. Then what will be the gravitational force between these two masses? So you have to use this equation, Newton's universal law of gravitation formula, F equal to g mm by d square. So you can solve this problem by using this formula, F equal to g, universal gravitational constant, capital M is small m divided by d square. So this is mass of Jupiter, this is mass of Earth, this is distance between these two objects. Okay, so you can do calculation by using this formula, you will get the answer. So for numerical calculation part, you must do it yourself. Okay, otherwise it will be very difficult to understand. Now next part we'll go to is question number 23. 22, question number 22 is very easy. It is from gas preparation, carbon dioxide gas preparation. So it is already done in the previous video. Now we are going to see question number 23. Question number 23. Draw a neat and leveled diagram of internal structure of human heart. So we are going to draw internal structure of human heart. I'll show you some techniques to draw so that you can draw it easily. Okay, so in the given figure A and B, which blood vessel carries blood from lungs to the heart and which has high blood pressure? Why? So these two blood vessels are given and you have to say which blood vessel carries blood from lungs to heart. Lungs to heart. The blood vessel which carries blood from lungs to heart is pulmonary vein, and pulmonary vein is actually an artery because it carries pure blood. It has characteristics of artery. Its name is pulmonary vein. This is the only vein which carries pure blood in the body. You know it. So this is an artery. That is why among these two, which one is artery, you have to find out. So this one is artery because it does not have valve in it. It has thick wall and it does not have valve in it. Okay, whereas this blood vessel has valve in it and it has thin wall. It is vein, it is artery. Okay, so pulmonary vein is this blood vessel. Okay, actually this is an artery. So the blood vessel which carries blood from lungs to heart is A, this one. It is pulmonary vein which does not have valve in it. Okay, so A artery has thick, high blood pressure because it has thick wall to exert pressure. So among these two, which has high blood pressure? This is your question. So among these two, artery has high blood pressure because blood flows in it with greater speed. Okay, so with great force, blood flows in this blood vessel with great force. Okay, exerting pressure on the wall. That is why the wall of artery is thick to withstand this pressure given by flowing blood. Okay, now whereas vein has thin wall, okay, because blood flows in it in slower rate. Okay, blood flows slowly, so there are chances of backflow of blood. So in order to prevent backflow of blood, there are valves to prevent backflow of the blood. So this is your answer. Now the first part of the question is draw a neat and leveled diagram showing the internal structure of human heart. So now we are going to draw human heart. I'll show you some techniques to draw. Hopefully it will help you. Okay, so we can start it this way. So first of all, you make M structure in it. So try to use the dots, try to draw by using dots in the beginning. Try to draw as lightly as possible. Okay, make dots so that it will be easy for you to rub out later on. There won't be much rubbing. Do not use dark lines, okay, in the beginning only. So this is the, from this middle point, this is straight down, here is the point, but you shift this point little bit this side, okay, because heart is little bit towards left side of the body, tilted towards left. Okay, so you can join. Okay, now after this you choose a, somewhere middle point over here, from where from this you draw T-shaped structure, kind of T later. Don't reach it too high, okay, up to here. Then second line you draw parallel to it by making dot lines, so that, okay, because there are other structures to fill in it, that is why don't draw dark line. Okay, you can be using dot lines for now. Okay, so T structure is made, right? Now from here draw S or semicircle structure from here, semicircle structure from here to here. Okay, make it cross somewhere over here. Make it cross somewhere over here in this manner. Now S later, or this is not complete S, this is kind of semicircle. Okay, now you complete this line, draw parallel to it, and try to draw 3 blood vessels on top. Okay, in this one, this way. Now bring it little bit down this end. Okay, now here, now you can complete this figure in this way, right? So make it overlap from top, right? Now after this, from this middle point draw a line straight down, okay, and draw parallel line to this one, outer line, and reach it till here, draw it till here, and again from this point draw another line parallel to this and draw it till here and make it parallel to this wall and reach till here, right? After this you try to pull it little bit bulging out, okay, and from here draw 2 vessels. This is pulmonary vein, okay, this is pulmonary vein part, and from here make it little bit bulging out, okay, this, yes, and this is vena cava, superior vena cava and inferior vena cava comes in this manner, right? And after this, this is bicuspid valve, complete bicuspid valve. This is opening downward. This is tricuspid valve. Okay, this is opening downward. Yes, and valve is present in these two also, which is opening upward. This one. This is aortic valve. This is pulmonary valve. Right, so with this we complete the figure. Now I am going to make this diagram darker by using black pen. But in your diagram you cannot use pen, you should not use ink pen in your diagram. Okay, so I am going to complete in this manner. So pencil lines can be rubbed out later on. Okay. And now complete this line aorta. This is aorta and this carries pure blood to all parts of the body. Okay, now after this you complete this part. Yes, this is superior vena cava. This is inferior vena cava. Okay, now this opens in this manner. Okay, now this one outer line. Okay, now this is the okay, now complete this line and you complete this line. Thick wall, there is thick wall in the ventricle. Okay, left ventricle is thicker than right ventricle. This is opening downward, this is opening downward, this is opening upward, this is opening upward. Okay, and you can add more muscular structures here in the ventricle, and left ventricle has more muscular structure here in this manner, right? So with this we complete the figure, and now label the diagram. Now we are going to label the diagram. Okay, so this one, 4 chambers of the heart. This is left auricle. Okay, this is right auricle, this is right ventricle, this is left ventricle. 4 chambers of heart, right? And you do labeling by writing complete words here. Okay, left auricle, right ventricle, left ventricle, right? 4 chambers. Now we'll go to blood vessels. Blood vessels, this is pulmonary artery, pulmonary vein, pulmonary vein, pulmonary vein, and this one is aorta, aorta, aorta. This one is pulmonary artery. Okay, now this is vena cava. These two are vena cava, superior vena cava and inferior vena cava. Yes, this is superior, this is inferior. Now this is pulmonary artery. Pulmonary artery, this one. Okay, and this is pulmonary vein. This is tricuspid valve. tricuspid valve. And this is bicuspid valve. This is bicuspid valve. Okay, this is pulmonary valve. This is pulmonary valve or pulmonic valve, and this is aortic valve. This one is aortic valve. Try to draw this line straight as far as possible. In my diagram, it is not happening so perfectly. So pulmonary valve, then aortic valve, this one, right? So I think this many. Yes. So 4 chambers have been done, valves have been done, blood vessels have been done. So this is the internal structure of heart. Your caption of your diagram is internal structure of human heart. Internal structure of heart. So this is your diagram. So you can draw your diagram in this way. So first of all, what we discuss is, first of all, you have to make M kind of structure here. Then you have to draw V, which should be tilted little bit towards left side. Okay, then after you draw this T structure in the middle, and after this you make this semicircle, somewhat like half S. Okay, but it is not complete S, up to this point only. And after this you complete this pulmonary vein, then pulmonary vena cava, then after this valves. Okay, then double line drawing over here. So in this way you can complete your diagram. So with this we finish internal structure of heart drawing with labeling. So for this you can write complete words: left auricle, right ventricle, left ventricle. Okay, so with this we finish this discussion.